So hello everyone, welcome back to another particular lecture series of our reagent chemistry course, and we are continuing our discussion of oxidation of alcohol, and this is the class 25. So in our previous discussion, we are talking about the PDC and PCC based oxidation reactions. Now in this particular part, in the last segment of our chromium based oxidation reagent, and here we are talking about the PFC and Etard reaction. So first, let us talk about the PFC in details. PFC's full form is pyridium pseudochromate, and it is a mild oxidizing agent for the primary and secondary alcohol, and the compounds with acid-sensitive group can be oxidized without buffering the reaction mixture. Because of that, it is a mild oxidizing agent and no acid, direct acid content is there. And also PFC can oxidize activated CH bonds. So now let us talk about that how that particular reagent PFC is generated. PFC is generated by treating with CrO3, HF and pyridine. When react, we get this type of composition, and this is the composition of PFC. And PFC will show control oxidation for primary and secondary alcohol. So this is the primary alcohol. Primary alcohol is generated after PFC treatment. It will generate aldehyde, and in the case of secondary alcohol, it will generate ketone. For example, here you can find here that I already discussed that PFC can also oxidize activated CH bond. So here in the presence of PFC, this oxidation takes place. So it is a very interesting example. And so you have to remember that thing. Also, as I already discussed, as PFC in presence of secondary alcohol generate ketones. So you can see here. And also CH activation here is also done like PFC in an acidic condition corresponding aldehydes. Now let's talk about our last segment, is the Etard reaction. Etard reaction suggests that the direct oxidation of an aromatic or heterocyclic bound methyl group using chromyl chloride. So here the reagent for Etard reaction is the chromyl chloride, and the solvent is fairly DCM. It's mostly used. And what should be the mechanism of this particular transformation methyl to CHO? Basically, it proceeds through a formation of a chromyl ester intermediate during the reaction that we'll discuss in our mechanistic pathway slide, and it is the common method to oxidation of toluene to benzaldehyde under mild condition. So this is an important reaction. So now let us talk about the mechanistic pathway. So mechanism is little bit tricky here. So what should be the mechanism? That initially a in reaction is generated. So this particular this particular bond as goes here, and this particular double bond is actually attack here chromium center, and this oxygen bond is opens up. So this type of intermediate is generated, and this particular oxygen are actually captured this hydrogen here to make this intermediate. And after that, you can find here that this is 1, 1, 2. And this is 1, 2, 3. So that means that 2, 3 sigmatropic rearrangement takes place here. That the similar thing that is observed in the case of Babler oxidation also, where is the 3 plus 3 sigmatropic reaction. But in the Etard reaction, 2, 3 sigmatropic rearrangement is observed. And after doing 2, 3 sigmatropic rearrangement, this type of intermediate is generated. Now, in presence of base or in presence of intermolecular chlorine here, it will actually capture the hydride here, and then this particular bonds goes here, and the particular rest of the chromium part goes out of the mechanism, out of the reaction mixture, and then we finally found this type of aldehyde, benzaldehyde. So what should be the limitation? The limitation is that with this particular reaction condition, multiple product formation possible depending upon the starting material or the intermediate is generated. So this is the main issue of Etard reaction. So with this, we have to end this particular short lectures. So in the next class, we talk about the manganese based oxidation reagents. This is especially MnO2. So thank you for listening.